viewers, welcome again to the continuation of the video, which is differential equation. Don't forget, I promised yesterday to upload the continuation of the video. We stopped at formation of differential equation. That is, we are starting from formation of differential equation. Don't forget, yesterday we treated the definition or meaning of differential equation. We also explained orders of differential equation. I also explained or expatiated the meaning of general and particular solution. Now, how do we form differential equations? We have three questions here to tackle. These three questions will explain comprehensively how we can form any differential equation. In this example, we are to form the differential equations of the following functions. We have number 1, we have function number 2, and we have function number 3. These are not differential equation yet, but we want to form the differential equation. Don't forget, you might have different order when you are forming this differential equation, like first order, like second order, and so on. Now, what are we to do here? What we should put in our mind is we want to eliminate or find a way to cancel completely all these arbitrary constants. Like in function A, we have in function 1, we have A and B as a constant term, and we want to eliminate A and B. In this second question as well, we have A and B. We don't want to see A and B. And in this third question, we have A. We don't want to see A. And how do we go about this? Let's go. Number 1. This is the question. Y is equal to A cos x plus B sin x. Now, the first thing you are going to do is you differentiate. Let's differentiate. The y, the x is equal to, when you differentiate A, or when you differentiate cos x, we said it's going to be minus sin x. The derivative of cos x is minus sin x. Therefore, this will be minus A sin x plus, when you differentiate cos, you are going to have cos x. That is, if you differentiate sine, you will have cos. If you differentiate cos, you have minus sine. Now, I want to differentiate sine x. Then I will have cos x. This b is constant. I will have b cos x. Now, what are we going to do? There's no way we can eliminate A and B at this junction we are. What do? We have to differentiate again in order to see what we can do, in order to eliminate A and B. You agree with me? If I differentiate this in second term, I will now have second degree order, like the square y, the x square. If you differentiate sine, I told you we are going to have cos. This will be minus A cos x, and if you differentiate cos, you are going to have minus sine. Then this will be minus B sin x. Now, at this junction, we can factorize. What is common here? Minus is common. If I take out this minus, I will have the square y, the x square, equal to minus, that is, I'm taking out this minus. I will have A cos x plus B sin x. A cos x plus B sin x. if you look at this, you discover that a cos x plus b sin x is still the same thing as the original function given here. That is, y is equal to a cos x plus b sin x. Instead of repeating a cos x plus b sin x, we can easily write this y, that is, this will be equal to y. Then we need to stop here since we cannot find a and b anymore. This will be the square y, the x squared equal to minus y. And when this comes here, you can have the square y, the x squared plus y equal to 0. And this is second order of differential equation. We have formed a second order of differential equation from this given function of y equal to a cos x plus b sin x. Now let's go to the second one. The second question here, we have y equal to a x squared plus b x. Y is equal to ax squared plus bx. And what are we going to have here? We are going to differentiate. When you differentiate this, you have the y, the x equal to, differentiate x squared. We are going to have 2x. So we have 2ax plus, when you differentiate x, you are going to have 1. Then we left with our b, that is b times 1. Now, can we find the value of a and x here? I don't think so, because we are having two arbitrary constant terms there. Now what you are going to do now is we differentiate again. Let's call this equation 1. If you call this equation 1, and we are going to redifferentiate this. If we redifferentiate this, we are going to have second degree order, which is the square y, the x squared equal to, when you differentiate x here, you are going to have 1. Meanwhile, 2a, they are the constant terms there. So when you differentiate x and you have 1, then you are going to have 2a. Then plus, when you differentiate b, the answer will be 0 because b is a constant term. It does not contain x. Now we are left with ordinary a, no more b again. What I will do now is I will find the value of a here. I will now substitute this value of a into this equation 1. Then from this equation 1, I will get my b. I will now substitute the values of a and b back to this original function here. Then I will now have my degree of differential equation. So let's find the value of a here. You agree with me that here I will have the square y, the x squared equal to 2a, and when you divide both sides by 2, we are going to have a equal to 1 over 2 the square y, the x squared. And we can just substitute directly these 2a for the square y, the x squared. That is, 2a is the square y, the x squared. Instead of making a directly subject of formula. So whichever way we do it, we are still going to have our answer. What I will do now is I want to substitute this. I want to substitute this for this in this equation 1. And I will have the y, the x equal to 2ax plus b. This is my equation 1. And when you substitute this, if you substitute this for this, Then I will have the y, the x equal to this will be the square y, the x square. The square y, the x square, then into x, then plus b. From here, I can find the value of b by making b subject of formula. Or I will just substitute for b directly into this equation. So let's go there. Let's see what we are going to have. I will have the y, the x equal to x, the square y, the x square plus b. And when you make b subject of formula, we have b equal to the y, the x minus, when this comes here, we have x, the square y, and the x square. So now I can substitute this for b in this particular function here. Then I will substitute this for a in this particular function here. And if I do that, what am I going to have? So now, let me substitute this and this into this function. I will have y equal to a x squared plus b x. So our y equal to, what is our a? Our a is 1 over 2 the square y dx squared. The square y, the x squared, then plus b. What is our b? This is our b. So we are going to have b, that is x, into b. And our b is the y, the x minus x, the square y, the x square. So I'm copying directly from here and from here. Now let's simplify this. We are going to have y equal to 1 over 2 the square y, the x square, then plus, so this time this will give you x, the y, the x minus x square, the square y, the x square. So anything common? No. Let's rearrange this. When we rearrange this, we see that this and this. So let's rearrange. So let this come here. It will be x square, the square y, the x square, followed by this minus 1 over 2 the square y, the x square, then minus, or let's take this to this side. We are going to have x, the y, the x. So when this comes here, minus y, and I will have a factorize. I will take this out, the square y, the x square into x squared minus half equal to x, the y, the x minus y. So now I can find the LCM of this to clear the fraction if I like, or I will leave it in that form. So we have, I have to find the LCM of this. So this will be the square y, the x square, then into this will give you 2x squared minus 1 all over 2 equal to x dy dx minus y. So when you multiply everything by 2, we are going to have the square y, the x squared into 2x squared minus 1 equal to what? So this will give you 2x dy dx minus 2y. And this is the same thing as the square y, the x squared into 2x squared minus 1 minus 2x dy dx equal to minus 2y. It's either we leave our answer like this or we arrange it like this. So this is the differential equation, and this is the second degree order of the given function, which is this. So now let's look at the third one. So let's go to the third one. We still have x here. We still have x here. So this x, we need to put x. Okay. Sorry. This should be a. This is our a to be x squared. And here will be also x squared. This should be x squared. So this is x squared as well. X squared. This is x squared. So this will give us x squared. So this will give us x squared. X squared. So if there's x squared here, we still have over 2. So this will be x squared. So we should be x. So this will be x. We have the square y, the x squared, which is x squared minus 2x dy dx equal to minus 2y. So this is the differential equation of this order, or we can divide everything to single this y. We can also write this as, instead of multiplying everything by 2, we can also leave it as x squared over 2. The square y, the x squared minus this will be x, the y dx, then minus y equal to plus y equal to 0. This is second order of differential equation. Let's quickly look at the third one. Don't forget, we want to find the value of a here. So when you differentiate, you have the y, the x, equal to differentiate this to give you x. Then when you differentiate this, that is, we are differentiating fraction 1. Let's say you have a over x, and this is fraction. You apply quotient through the y, the x here. You put down the bottom, which is x. Differentiate the top, 0 minus put down the top, which is a. Differentiate the bottom, which is 1, then you square the bottom, x squared, and this will give us minus a all over x squared. Therefore, the derivative of this, when you differentiate this, is going to be 1, and the derivative of this will give you minus a over x squared. Now let's find the value of a. We can easily find the value of a here and substitute to this. So let's call this equation asterisk, and from this, let's call this 1. From this equation 1, our x will be, if you make a subject of formula, we are going to have a xy equal to x squared plus a, and when this comes here, we have x y minus x squared equal to a, and when you factorize, we have x into y minus x equal to a. Now I want to substitute. So we have, this is our a. We want to substitute this a now to this, and we now have from here as dy, the x equal to 1 minus a, and this is a, x into y minus x all over x squared, So we can also write this as the y, the x equal to 1x, we take care of 1x to have 1 minus y minus x all over x. And if we clear the fraction, we are going to have x, the y, the x equal to x minus y minus x. So we can also clear the fraction. Let's clear the fraction. So we have x, the y, the x equal to, I'm copying from this place, to be equal to x minus y minus x, and this will give us x, the y, the x equal to x minus y plus x. This time this, this time this, and we have x, the y, the x equal to 2x minus y. And if we rearrange this, we are going to have y, the y, the x, then plus y equal to 2x. So this is the differential equation of this function. Thank you so much. We are going to stop here. Tomorrow or in the next class, we shall be looking at how we can solve differential equations. Help me to subscribe. I love you all. Bye.